Siemens EDA essentially provides EDA tools for semiconductor development and design. Our Tessent product line is based on design for test, so all of the test technology that goes into your semiconductor to enable manufacturing test and also in-field test. And what we're seeing at the moment is a shift towards what we're calling SLM, Silicon Lifecycle Management, where there's a greater requirement to be able to monitor and understand what's going on with the silicon when it's actually in application out there in the field, to ensure a better quality and make sure the silicon is lasting longer, and we have a better understanding of how the silicon is behaving. And in terms of products, we have a complete range of products under the Tessent banner, and our most recent flagship product is called SSN, Streaming Scan Network, which is really an industry-defining product for test, enabling us to packetize and stream the test data onto the chip on a dedicated bus, making the implementation of test far simpler and really optimizing cost and performance of test once the device is in silicon.
So for them it's important to provide security as an enabler to take more advantage from Siemens product from a customer perspective. So the test data or analytical data that comes out, if can be remotely accessed or can be accessed by different players on the supply chain, that adds a lot of value to the overall supply chain from a customer perspective. And our root of trust, Mars or Q-root, that sits within Siemens products, provide that layer of security and separation between access control of who have access to what data and when securely to have those benefits from Siemens products as an end user throughout the silicon lifecycle.
We're moving into an era called SLM, so Silicon Lifecycle Management, where we're adding additional complexity and technology to the chip to be able to extract critical reliability and performance data from that chip. Now, this is done in an in-field manner, which means it's done out in the field. So we need to be able to protect that. So adding security to our DFT infrastructure is absolutely critical. So the challenge is really bringing that whole concept around security to our customers and making sure that all of the infrastructure that we introduce doesn't open up any holes in their security of the chip, and we're actually improving the overall security of the chip by adding technology such as the technology provided here by Crypto Quantique, which is a lightweight root of trust there that's called Mars, which fits extremely well with our whole DFT Tessent infrastructure. I see security as being one of the pivotal points of getting the whole Silicon Lifecycle Management infrastructure out there, making sure the data that we collect from the chips is secure and accurate. So I see security as being a really big topic over the next few years as we kind of continue to move in this direction. And without security, I see some real challenges around data security in this SLM environment. So it's really a critical technology to make that happen.
I am excited about the future of security. I think it's been a long journey since we started back in 2016 and telling people about chip-to-cloud security and the importance of achieving that for different products. And industry moved slowly but surely towards that direction, and now we're seeing how serious different businesses are, how they are realizing that security can enable a lot of new features that are very valuable to the end customer, and kind of moving to that direction. And with new technologies, with new way of securing from post-quantum cryptography, the AI kind of capabilities around and the impact of that on security, there are exciting years ahead. How new products can be developed to provide security, but also how existing products are coping with the security requirements moving forward.